Hello everyone. Today's seminar lesson, I'm gonna show you how to solve integration problem using different strategy. Okay, so if you're given a integral expression and you are asked to evaluate, there are many possibilities to solve it, right? So for example, the first case is if I was you, I would look into a simplification of my integrand. So simplify the integrand if possible, right? Step one is you simplify it if possible. Okay, for example, this problem right here, I have the integral of square root of x times the quantity of 1 plus square root of x dx. So what I did is I distribute the square root of x into the parentheses. So I have the integral now is square root of x plus x dx, right? So what I'm going to do next, I'm not going to solve for this, but I'm just going to show you. What I'm going to do next is I'm going to split this into two integrals, right? So the first one will be square root of x. Instead of writing it square root of x, I'm going to write it x to the 1/2. And then the second one is just x. And now you can take the antiderivative easily, right? You can integrate it easily. Okay. All right. The second thing is, which is very popular, is use the U substitution. Okay, which is very popular. Use U substitution whenever you can. Okay, that's the easiest form. The third is you classify the integrand according to its form. Either you can integrate it by parts or using trigonometric integration. For this part right here, I have a video about that. You can check that out, right? Or partial fraction, right? You break in your fraction into little fractions, so that it would be easier to take the integration. Okay, or if none of these above, then try again, right? Manipulate your integrand or something. We can even have to use, or sometimes we even have to use several methods to solve. Okay, so just manipulate, massage your things around. Eventually you'll be able to solve for it. Okay, I don't think your professor is going to give you something that you cannot solve or something that require like graduate knowledge. Okay. All right, so for the example, I have integral of 5x plus 3 size x, all of that square. So the first thing I'm going to do is I'm going to expand this. Okay. So it's equal to, if I expand this, it's equal to, you can FOIL it, or you can use Pascal's triangle, which I'm going to do. So it's going to be 25x squared plus 2 times 5 times 3 is 30x size x plus 9 size square x, and all of that dx. Okay, now the first one is easy, right? The first one is easy. This one right here, maybe I'll highlight in black, right? I highlight in black. That one right there is it's easy, right? All you have to do is just take the antiderivative of that, which is 25x cubed over 3. Right? So this part right here is equal to 25x cubed over 3. How about the second part? This one right here. Maybe I'll highlight it in blue, right? So this one I'm going to use integration by part. So what I'm going to do is I'm going to let u equal x. So du equal 1 dx. And then the dv part is size x dx. Okay, so v will be minus cosine x, just minus cosine x, right? And now uv minus integral of v du, right? V du, which is equal to uv is minus x cosine x minus integral of v du. V is minus cosine x. Du is just 1 dx, so just dx. Okay. Let's clean this up a little bit. So equal to minus x cosine x plus minus minus becomes plus integral of cosine x dx. Okay. I'm rewriting this negative x cosine x plus antiderivative of cosine x is sine x. Right, so plus sine x. Sine x. Okay. So let me box things up so we don't forget. Later we have to combine them. So this is our result. One of the results. Right? One of the results. Okay. So that's the second part. Now the third part, maybe I'll highlight it in green. Right. That one. That one is, let's see, that one, I'm going to use the power reduction formula, right? Power reduction formula. Let me remind you what the power reduction formula is. If I have sine square x is equal to 1/2 1 minus cosine 2x. Okay, so this one right here is 9. I'm going to bring the 9 to the front. Integral of sine square x is 1/2, right? 1/2 1 minus cosine 2x dx. Or we have 9/2 integral of 1 minus cosine 2x dx. Integral of 1 is just x. Using u substitution, cosine of 2x is sine of 2x over 2. Right? This is very popular one, and it's simple, so you can do it yourself on this on the side. Okay. Okay. So now I can combine them all together. Right now I can combine them all together. Let me write out the last. Let me distribute the 9/2 in and write it out. So be 9/2 x minus 9/4 sine of 2x. Now, if your professor is doesn't like that size of 2x, you can use one of the trig identity. I believe it's double angle formula. It's called double angle formula. You can rewrite it one more time. So be 9/2 x minus 9/4 sine x cosine x. Okay, so from here to this one. Okay, that's the double angle formula. Right? Maybe your professor is being picky about that, or maybe you have to enter in on like website, one of the software homework. They kind of picky about the answers. So whichever one, okay. I think the website would like to have the latter one, prefer the latter one. Okay. All right, now we're going to combine all three results. So the final answer is 25/3 x cubed plus sine x minus x cosine x plus 9/2 x minus 9/4 sine x cosine x, and don't forget the constant. Okay. Oh, I think I forgot something. I forgot the 30 in the blue part here. I forgot the 30. Maybe I'll do in purple. You can see what I forgot. I forgot to bring along the 30. That's what I did. So it'll be 30 here. 30 here. 30 here for all of them. Okay, so so this one should be a negative 30 here plus 30 sine x. Okay, yeah. All right, looks good. Looks good. Okay, so that will be our final answer. Thank you for watching.